here are Lewis Dott's notes drawing them. Again, take a picture of this top part right here. Or you don't need to copy it down, but I would take a screenshot or a picture of it just so that you have these steps. Hopefully soon you'll be able to do it without doing all these steps, but it will be good to know these steps for the beginning part. But I'm going to move on so we can get through this video. So, we are going to start drawing Lewis dot structures. You don't need to draw this, but up here you'll see we talked about doing a Lewis dot structure for hydrogen and oxygen for water the other day, and we drew something like this. And so we're going to learn how to draw these things today. So one thing that you do need to know that I would write down is that if you have a dot, that equals 1 electron. And if you have a line like this, that's a bond, and that equals 2 electrons. So the elements will be sharing an electron, and an electron, they'll be sharing 2 electrons. That will be really important. So you'll notice that I have made some pro tips of things that aren't in this list of the steps for the Lewis dots. So steps for the Lewis dots are going to be counting number of valence electrons, putting the thing that can make the most bonds in the middle, bonding to other elements, placing electrons to fill octet, and then double checking your work. But I'm going to give you a couple pro tips that will help you as you're working through these problems also. So the first pro tip is to make sure that everything besides H has an octet, or 8 electrons around it. Remember, we always are trying to get to 8 electrons around our thing. So I'm going to write it down. You should probably write this down in your notes. Oops. Besides H, or hydrogen. Alright, that's our first step. Our next pro tip is to look at your Lewis dots to see how many bonds it can make without having a charge on it. So, if you remember Lewis dot structures for like carbon, this is what its Lewis dot structure was. Nitrogen, this is what its Lewis dot structure was. Oxygen looks something like this. And then things like fluorine or chlorine looked something kind of like this. So each of these will kind of show you how many bonds it wants to make. If it doesn't make this number of bonds, it's going to have a charge. We talked about in the previous video charges, formal charges. So if it doesn't make this number of bonds, it's going to have a formal charge. So usually, unless there's a charge on your molecule, you're going to want to make these certain number of bonds. So for carbon, it's going to always want to make 1, 2, 3, 4 bonds. Nitrogen is always going to make 1, 2, 3 bonds. Oxygen is always going to want to make 2 bonds, and fluorine is always going to want to make 1 bond. So that's something really important to keep in mind. It also leads to our next pro tip, which is that usually your carbon wants to be in the middle. And then usually, you'll also remember H's Lewis dot structure looks like this, so it always wants to make just 1 bond. So usually your hydrogen and things called the halogens, they're things in group 7A, like fluorine, chlorine, those ones want to be on the outside. So these ones aren't hard rules that you always follow, but generally, besides the first one you always need to follow. This first one, everything besides H needs to have 8 electrons or a full octet around it. You always need to follow that. So that means like this oxygen, if you go up to the top and you look at that, this oxygen, it has 2, 4, and then remember 6, 8 in these bonds. So it has 8 around it. So everything needs to have 8 around it besides hydrogen. So now let's get going drawing these, and as you have questions, you can pause the video and email me. Hopefully, as the video goes though, it'll make more sense and you'll see some patterns and you'll be able to follow along. So, let's start off with doing F2. Alright, we're going to draw Lewis dot for F2. Now you'll notice our first step, our number 1 step, is to count the number of valence electrons. So you look at your periodic table and you go to the top and you look how many valence electrons does F have. F has 7. Now you'll notice in this example, we have 2 F's. So for F2, we're going to need 7 times 2 for 14 valence electrons. So at the end, we need to make sure we have 14 valence electrons. The second step says to put the thing that can make the most bonds in the middle. We only have 2 elements, so there's going to be no middle. So we just want to bond our 2 elements together. So we're going to have an F bonded with another F. All right, then we need to make sure that we place the other electrons to fill our octet. So again, things need to have 8 valence electrons around it, right? That was this step. So F right now, it has 2, and then we need to do 4, 6, 8 around that one. This one has 2 as the bond, and then 4, 6, 8 around it. Right, good. So let's see if we used 14 valence electrons like we were supposed to. So we have 2, 4, 6, 8, 10, 12, 13, 14. So we've used 14 valence electrons. This down here is the Lewis dot structure for F2. That's what it looks like. All right, let's move on to our next one. And let's see if we can follow our rules and figure this one out. So we're going to have NH3. Now first, let's figure out the number of valence electrons. So N wants 5, H usually wants 1. It's going to be times by 3, so it's going to be 3. So total, we want 8 valence electrons used. Now our next thing is that this one does have multiple, not just 2 elements, or 2 elements, it's going to have 4. So we need to put the thing that can make the most number of bonds in the middle. So if you look at this line right here, you'll see C wants to make 4, N wants to make 3, this H just wants to make 1. So our N is going to go in the middle. So we're going to have N, and N wants to make 3 bonds. From our Lewis dot structure, we can see it has 1, 2, 3 dots. It wants to make 3 bonds. So N is going to bond with H once, H again, and then H a final time. That's perfect because we've used up all of our elements now. And now we just need to make sure that that everything besides the hydrogen has 8 electrons around it. So right now, if we look at this, this is 2, 4, 6. So then we need to do 7, 8. We also, this is lucky for us because we know that our number of valence electrons we're trying to get to is 8, and we know that it has 2, 4, 6, 7, 8. So that is your Lewis dot structure for NH3. All right, let's move on to a next one. Oh, sorry, the other notes are down there. Let me erase some stuff and then we'll move on to our next one. So the next one that we're going to do, let me write it down so you can maybe get started on it, and then I'll finish. I don't know why these didn't erase. Let me write it down so you can start on it, and then I'll finish erasing. So how about you get started on making this one, CCl4. You can speed up the video if you don't want to see me erasing, but get started on CCl4. Alright, so carbon normally has 4 valence electrons, chlorine has 7, times it by 4, so that equals 28. So total, we should have 32 valence electrons around this. So we're going to start off with C in the middle, because remember, we always want to start off with the thing that can make the most bonds in the middle. Carbon can make 1, 2, 3, 4 bonds. It wants to go in the middle. We also know carbon wants to be bonded to 4 things, so we're going to bond it to 4 Cls. Because we have 4 Cls to use. Now you'll notice that carbon, remember, everything wants to get 8 electrons or a full octet around it. So carbon has 2, 4, 6, 8. So carbon is happy and full right now. So we just need to add valence electrons to all those Cls, because all the Cls right now just have 2 electrons by that bond. So now we need to add valence electrons. We need to add 6 of them because they already have 2. They're trying to get to 8. So we're going to add 6 valence electrons around the Cls. And then when we're done with this, we're going to count and make sure that we hit 32. Alright, now we're going to count. So we have 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. Yay, we made it to our 32 number. So this right here is the structure for the CCl4. Alright, your final one is going to be a little bit tricky. It's going to be CO2. Alright, so first figure out your valence electrons. We have 4 for C. We have 6 for oxygen, times it by 2 to get 12. So if we add them up, we should get 16 valence electrons for these. So we're going to put our carbon in the middle, and we're going to put our O's bonded on the outside. Now you'll notice the problem here is that carbon normally wants to make 1, 2, 3, 4 bonds. Right now it's only making 2 bonds. So we'd either need to add a lot of valence electrons or we need to make it bond. You'll also notice the oxygen wants to make 2 bonds, and here it's only making 1 bond. So in chemistry, some elements are called double bonded, where they're bonded to the element again. So carbon is now going to be double bonded to oxygen. This helps carbon get all of these 4 that it wants to have bonded. Oxygen wants 2 bonded, so it helps them both be happy being bonded here. It also helps our carbon in the middle have 2, 4, 6, 8. So it has 8 around it. Now both of the oxygens still need electrons, so they have 2, 4. So we need to do 6, 8, and then we need to do 6, 8 around that one. So now that they all have a full octet, let's count to make sure. So we have 2, 4, 6, 8, 10, 12, 13, 14, 15, 16. So 16 valence electrons, we hit our goal. This is what it looks like. So sometimes you're going to want to do double or triple, even triple bonds to get it so that everything has a full octet. That you follow this step will help you know if you want to do a double or triple bond, because it tells you how many times it wants to bond with something. But those are some good rules to follow. Hopefully this video is a little bit more clear than the last video. You'll notice on your homework I'm going to make a video about that, but there are some ones that have charges on it, so make sure to be careful with your electron counting there. But hopefully this is more helpful. Please email me or come in and get help, because I know this is kind of a tricky subject to get down. Good luck, guys.